Now problem is solved or still experimenting? Okay, thank you. અચ્છા હવે ટાઈમ કેટલો ક્યાં સુધી લેવાનું છે? ટાઈમ આપણે એક્સટેન્ડ કરવાનું છે કે ઓકે ઓકે ડન.
Can I start?
Yes, from my side done.
Good morning to all of you. KA School of Business Management, in association with Department of Mathematics, Gujarat University, welcome to all on the fourth day of the UG level Fundamental of Mathematics 2020 workshop. Our today's speaker is Dr. Dushyant Patel. He has completed his PhD in the year 2015 from Department of Mathematics, Gujarat University. He has total 15 years of teaching experience in the field of mathematics. He has published 27 articles in various national and international journals. Since 2011, he is working as a lecturer in a government polytechnic college, Ahmedabad. So now, I, Muskan Kalwani, invite Dr. Dushyant Patel to deliver a lecture on a relation and function.
Thank you, Muskan ma'am, for my introduction. First of all, let me share my screen. Is it visible? And we are live on YouTube now. Voice is audible. Okay. Link is changed or it is same for YouTube? Hello. Okay, so let's start our topic, relations and functions. And sorry for inconvenience to all the participants due to some technical problem. Our lecture was bit delayed, but we will try to complete within time. So relations and functions, this topic is very much useful for calculus. And calculus is very essential for everything, engineering, computer, etc. Because whenever we are dealing with change, then calculus appears. So for calculus, relation and function is very basic. So we start with it. In introduction, Descartes has used this function word first time, and then it is modified. And currently, we are using the definition of Dirichlet and George Cantor. So what is a relation? You have already studied set theory, Cartesian product, etc. So if I take two sets A and B, where A is ABC, 3 elements, B is CD, 2 elements, then the Cartesian product of A and B will be the ordered pair AC, AD, then BC, BD, then CC and CD. So there are total 6 ordered pair in this Cartesian product. So further, for the set n of natural numbers. So natural number contains elements 1, 2, 3 and so on. Only positive numbers. We start with 1 and integers. So the relation of being double means if I take a number, we will make it double, and that is a relation. So 1 with 2, because double of 1 is 2. 2 will be related to 4 because double of 2 is 4. 3 will be related with 6 because double of 3 is 6, and so on. So in place of writing like this, we may write them as ordered pair. 1, then double of that, that is 2, 2, 4, 3, 6, 4, 8, and so on. Hence the relation can be expressed as a set of 1, 2, 2, 4, dash dash. We note that this is subset of n cross n. N cross n is containing infinite number of elements. So from that, these are the elements. So this set is a subset of n cross n. So in general, for any non-empty sets A and B, A and B must be non-empty set. Non-empty means there must be at least one element in set A and set B. Then a subset of A cross B is called a relation from A to B. So means if I take all the Cartesian product of A and B, then any subset of that Cartesian product is called a relation from A to B. For the sets A and B discussed in above example, ACBD is a relation because we have seen there were 6 elements you can see here. So here I have taken only 2 pairs. ACBD is a relation from A to B. Since the elements in A cross B was 6, it is denoted by N. A cross B means number of elements in Cartesian product of A and B, that is 6. The number of subset will be 2 to the power number of element, that is 2 raised to 6 is equal to 64. So there are 64 subsets are possible of A cross B. So all 64 are the relations from A to B. Thus above relation is written as S is equal to ACBD. Suppose for this relation, this A and C, BD is related with something, and we call this as S. So this is a relation. Further, as we have discussed, any subset S of A cross B is a relation from A to B if a pair XY belongs to S. Means, for example, if I am taking any pair XY belongs to S where X is in A, Y is in B, and when we take its Cartesian product, we are getting this pair XY. So that XY belongs to S. That means this X is related with Y with our given definition or whatever we have taken. In the example, A is related to C, B is related to D. If a pair XY belongs to A cross B, but XY does not belongs to S, then we say that X is not related to Y by S. Suppose in S, AC and BD. Suppose if I want to write AB, can I write? So no. AB is not related, whatever relation is defined. AB is in Cartesian pair when we have taken Cartesian cross product of A and B, but AB is in not in S. So AB is not related with this relation S. In some other relation, it may possible. So if S is a relation from A to B, then A for this pair AB, A is called the domain, and this B from the pair AB is called the range of S. So in the above example, the domain of S is AB and the range is CD, because you can note here XY in XY form X is A, here in XY form X is B. So this A and B are the elements of domain. Similarly, in this pair XY, this C is in terms of Y, and similarly this D is in terms of Y. So C and D are is in the range. So a relation S from A to B is said to be empty if S is equal to 5. Suppose we have so many subset Like in the previous example, we have seen that in A cross B, there are 64 possible subsets are there, in which phi is also a subset. So if I take a phi as a relation, then that relation is called empty. A relation S from A to B is said to be universal. If I take all the 64 elements, then this relation will become universal relation. Further, if A and B both are same, means our we are taking Cartesian product of A cross, instead of A cross B, we take A cross A. Then the relation S is called a relation on A. Let's take directly example 1. If I have taken A is equal to 1, 2, dash, dash, up to 10, means there are 10 elements. In B, set B, I have taken 3, 6, 9, and 12. So there are only 4 elements. So in A, there are 10 elements. In B, there are 4 elements. Let the relation from A to B be given by S is equal to AB, where A is multiple of B. So friends, be careful here. So we are defining relation. How pair is related? So AB, when we call that AB is related, if and only if this A is multiple of B. So if A is multiple of B, then we say that AB is related by relation S, because we have defined relation in this manner that AB is related if A is a multiple of B. So I hope it is clear. Now we have to find the domain and range of this set S. So here S will be, so let's take first element of B, that is 3. So what are the multiples of 3? So multiples of 3 are 3 into 1, 3. Then 3 into 2, 6. 3 into 3, 9. 3 into 4, 12. So 3, 6, 9, 12, 15, 18, and so on are the multiples of these 3. But out of them, how many are there in A? So in A, we have 3, we have 6, we have 9, but we don't have 12, 15, and so on. So we will write pair in this form, that 3, 3, then 6, 3, then 9, 3. Okay, so this 3 element, I hope it is clear. Now take 6. What are the multiple of 6? So multiple of 6 are 6 into 1, that is 6. 6 into 2, that is 12. 6 into 3, 18, and so on. So out of them, how many are present over here? So only one element, so that is 6. So here in our relation, there will be pair 6, 6. Then 9. What are the multiple of 9? 9 into 1, 9. 9 into 2, 18, and so on. So in our relation, which pair will appear? So here 9 is there. So 9, 9 is related. Now what are the multiple of 12? So multiple of 12 are 12 into 1, 12, 12 into 2, 24, and so on. So how many are presents are there in multiple of 12? No one. So 12 is not here. So here we have only 5 ordered pair in this relation. And what is the relation? Relation is this: in AB, A is multiple of B. So here, what are the domain? So in domain, we have this 3, 6, 9. So domain of S is 3, 6, 9. And in range, this 3, 6, and 9. So in this case, domain and range are same, but that is not the case every time. Second example, here, friends, you have to see the relation. What is the relation? So the name of relation is S, and how they are related. Ordered pair AB is related. When they are related, if A plus 2 times of B is equal to 15. Again, how this pair will exist in S? So for any pair to be in S, यानी S के अंदर होने के लिए A और B के बीच में क्या रिलेशन होना चाहिए? तो A plus 2 times of B must be equal to 15. And we can take any element from N. N cross N, only this condition must satisfy. And we have to write S in a roster form and also find the range and domain of S. So let's see how to solve this problem. A plus 2B must be equal to 50. Since we have taken relation on N, so A cannot be 0. A will be at least start with 1. So for this relation, 2b is definitely less than or equals to 15. So for b, what are the possibility? Let's take 1. So 1 into 2 is 2, which is less than 15. So yes, b could be 1. Let's take b is equal to 2. So 2 into 2, 4, which is less than or equal to 15. So 2 is there. Then 3 into 2, 6, and so on. 4 into 2, 8, 5 into 2, 10, 6 into 2, 12, 7 into 2, 14. But if I take 8, 8 into 2 is equal to 16, which is greater than 15. So I cannot take 8 as B. So for B, we have this possibility 1, 2, 3, 4, 5, 6, and 7. Now, for this relation, what could be the value of A? So if B is 1, then 2B is 2B will be 2 for B equal to 1. So this is 2. So for addition to be equal to 15, what should be A? A must be 13. So 13 plus 2 times B, that is 1, will be 15. So here when B is 1, A is 13. So we have this pair 13 and 1. So this pair is satisfying the relation A plus 2B is equal to 15. Next, for 2, what will be the value of A? So that will be 11. So 11 plus 2 times B, that is 2 times 2. So 11 plus 4, that is 15. So when 2, the value of B is 2, A will be 11. When value of 3, B is 3, the value of A will be 9. When value of B is 4, A will be 7, and so on. So we have these many possible pairs from n cross n, which is satisfying the relation which is A plus 2 times of B is equal to 15. So here, what is in the domain? So in domain, we have this 1, 3, 5, 7, 9, 11, and 13. And in range, we have 1, 2, 3, 4, 5, 6, 7, because the value of B will be in the range and the value of A, which is satisfying our relation, will be in the domain. So I hope from this example, what is a relation is clear. How to find domain and how to find range is clear. So we are skipping example 3 as we have short of the time. Let's see this example. Let O be the set of odd natural numbers. So what are the odd natural numbers? 1, 3, 5, 7, 9, and so on. So O containing these elements. And E be the set of even natural numbers. So even natural numbers will be 2, 4, 6, 8, and so on. So O is odd and E is the set which is containing even numbers. Now, here relation S, we have given the name to the relation is S, and AB is in this relation, in this set, when, so relation is defined here when A plus B is even. So if addition of this two pair is even, then that pair is related and that pair will be in the S. Next, T, another relation we have given name as T. So ordered pair AB is related when multiplication of this pair, that is A into B, is even. Means the product or multiplication of this pair must be even. So we have defined relation S when addition of A plus B is even. We have defined relation T when A into B is even. These are the relations from O to E. Now we have to find S and T, means what are the elements in the S and what are the elements in T, and we have to find domain and range of T. Now friends, if X is odd and Y is even, here O is the set of odd number and E is the set of even number. So if we add odd plus even, answer will be always odd. For example, if I am taking odd number as 1, even number as 2, so 1 plus 2 is 3, which is odd. So addition of odd and even can never be even number. So there is no ordered pair possible from this Cartesian product O cross E for which their sum is even. So we say that this S is an empty relation. There is no element in S which satisfy this definition for O and E, from the elements from O and E. Similarly, for T, A into B must be even. So if I multiply any odd number with even number, answer will be always even. For example, let's take odd number 1, even number 2. So 1 into 2 is 2. So 2 will be even. Let's take another example. Odd number 3, even number 4. So 3 into 4, 12, which is again even. So for all possible pairs from O cross E, every pair will satisfy this relation. So all pairs will be member of T. So what is T? T is equal to O cross E, means Cartesian product of O and E. So the domain and range of T are O. Domain is O and range is E. Now, how to represent this visually? We can also say this is an arrow diagram or Venn diagram. So we have seen that a relation from A to B is a subset of A cross B. A relation can be described using Venn diagram and also in tabular form. Let's take set A is equal to 1, 2, 5. So you can see in set A we have three elements 1, 2 and 5. In B, the elements are 2, 4, 6, 8, 10. 5 elements. So 2, 4, 6, 8, 10. Now we are defining relation S and how it is related. So AB is related if this B is divisible by A. Then AB is related, and in that case that pair will appear in S. So for any pair to appear in set S, what is the condition? That this element B must be divisible by this element A. So what are those elements? So 2. So 2 is divisible by, from which element? From this set A, by 1 and 2. So 1, 2 is there, 2, 2 is there. Similarly for 4, who will divide 4? 1 and 2. So 1, 4 is there and 2, 4 is there. 6, who will divide 6 from A? So 1 and 2. So 1, 6 is there and 1 2, 6 is there. Who will divide 8 from A? So 1 will divide, 2 will divide. So 1, 8, 2, 8 will appear. Similarly for 10, who will divide 10? So 1 will divide 10, 2 will divide 10, and 5 will divide 10. So 1, 10, 2, 10, and 5, 10. So these are the possible pairs which satisfy this relation, that is B is divisible by A. Now how we represent it using Venn diagram? So we have this Venn diagram here too. 2 is divisible by 1. So we will draw a arrow from 1 to 2 because it is related. Related by what? Related by the relation S, which is having this definition. B is divisible by A. Similarly, we can divide 2 by 2. So again there is an arrow from 2 to 2. So from A there will be two arrow towards 2. It will be from 1 to 2 and 2 to 2. There will be no arrow from 5 to 2 because 5 2 is not related because we cannot divide 2 by 5. Similarly for this element 4, who will divide 4? 1 will divide 4, 2 will divide 4. So there will be an arrow from 1 to 4 and 2 to 4. For next element 6, who will divide 6? 1 will divide 6. So there is an arrow from 1 to 6. 2 will divide 6. There is an arrow from 2 to 6. Now next, who will divide 8? So 1 will divide 8. One arrow. 2 will divide 8. Another 8. Another arrow. Now, who will divide 10? So 1 will divide 10, an arrow. 2 will divide 10, an arrow. 5 will divide 10, an arrow. So this representation is called Venn diagram, and this is also called arrow diagram. Second method, tabular method. So how we represents using tabular method? So see, here we have written the element of A, that is 1, 2, and 5. Here we have written the element of B, that is 2, 4, 6, 8, and 10. So if any pair is related, then intersection of that row and column will be mentioned by or denoted by 1. And if it is not related, we will denote it by 0. We have prepared this table for the previous example. So what was the relation? That B, element of B is divisible by the element of A. So here 2 is divisible by 1, so therefore it is 1. 2 is divisible by 2, therefore here entry is 1. 2 is divisible by 5, so 2 is not divisible by 5, so entry is 0. So we can divide all elements from 1, therefore all entries of this row is 1. We can divide all elements from 2, so all elements are 1. We can divide 10 with 1, 2, 5, so all elements are 0. All elements are 1. So if that element is divisible by A, there will be 1, and if it is not divisible by, then intersection of that column and row will be 0. Same form we can write in matrix form. So such matrix, such an arrangement is called an array or a matrix. Now friends, after getting the understanding of relation, we have to see function. For function, to understand function, relation, we should have knowledge of concept of relation. So we have seen what is a relation, what is Cartesian product, which pair will be in that relation, how relation is defined, and all. So now we are moving towards function. So function is nothing but a relation, but a special type of relation is called a function. So what is the speciality of that relation which make relation as function? So again start with, we should have two non-empty set A and B. That means in A and B there must be at least one element. If a non-empty relation F from A to B, a non-empty relation F from A to B has domain A, and for every x belongs to A, F contains one and only one, that is unique ordered pair containing x, then F is called a function from A to B and it is written in this form. We will call this as, or we will name this, or we will pronounce this like function F from A to B. Again, function F from A to B. This A is domain and B is codomain. This A is called domain and B is codomain. So what will be the formal definition of function? So let A and B be two non-empty set. Function F is subset of Cartesian product of A and B, that is A cross B, and F is not equal to 5, means in function there is at least one pair which satisfy. The function F from A to B is said to be a function if for all, this is the notation of for all, so for all x belongs to A, means if we take any elements from the domain A, there corresponds a unique ordered pair xy belongs to F, or we can also say there must be a unique element in B which is related to that element of x. The set A is called domain and B is called codomain of the function from A to B, and the set of F of order pair xy is also called the graph of function f from A to B. So roughly we can say function f from A to B will be called a function if first condition A and B must be non-empty set. Every element of A is corresponding to, or for every element of A there is a unique element in B. Then we call this f is a function from A to B. So for any element x in A, if it is related to more than one element of B, then it is not a function because there is a word unique. Unique means one and only one. So there must be a unique element in B which is the image of that element from A. Now let's see with this example. I have taken two choice, choice 1, choice 2. Here this arrow is defining that they are related. Now we have to check whether these are functions or not. So here this is domain, this is codomain. 3 is related to -1, 1 is related to 2, 0 is related to 2. So all elements have corresponding element in B and that element must be unique. So for 3, how many elements are there in codomain? Only one, that is -1. For 1, what are the elements in B? Only one element, 2. For 0, which element is there in codomain? So it's 2. So our choice 1 is representing a function. For every element of domain, there must be a unique element in codomain. Here we can observe that 2 is corresponding to two elements in the domain, 1 and 0. So no problem with that. 2 can be image of so many elements from domain. But for the elements of domain, there should not be more than one element in codomain. So choice 1 is clearly a function. Let's say choice 2. So these are the elements in domain 2, minus 1, 3. These are the elements in codomain 2, 3, minus 2 and 0. Let's see, 2 is related to 2. Minus 1 is related to 3 as well as minus 1 is related to minus 2. So friends, here we can see image of minus 1 or minus 1 is related to more than one element, 3 as well as minus 2. So this violate the rule of function that it must be related to unique element of b. So that is not satisfying here because minus 1 is related to 3 as well as minus 2. So there are more than one element. So clearly choice 2 is not a function. So from choice 1 and choice 2, which represents function? Only this one. Now let's take another function. Function is also known as mapping. So domain, there is only there is only one element which is 2. So 2 is related to A, 2 is related to B, 2 is related to C. So is it a function? Clearly no, because the element of domain must be associated with unique element. So here we are having more than one element. So this is not a function. Let's see this. A is related to 2. So image of A is only one element, that is 2. Image of B is 2. Image of C is only one element 2. So is it a function? Yes. Because for all the three elements there is a unique number in range, or we can say codomain, which is related. So B represents function, but A is not representing function. So B is a function. Now to check whether it is function or not, we have a very easy vertical line test. So what is vertical line test? A relation is a function if a vertical line drawn through its graph passes through only one point. How to check this? Let's see. This is also called the pencil test. We will move a vertical pencil, and we will move that pencil from minus x to plus x. In our x-axis, we will move from minus x will be from left hand side and x will be right hand side. So from left to right. If it crosses more than one point, then it is not a function. So let's take example of that. Uh, this is the graph of the graph representing a relation. Let's check whether it is function or not. So what we will do, we will take a pencil. We have put in on minus x-axis, that means on the left hand side. Now we will move this pencil from left to right. If it will intersect only one point everywhere, then it will be a function. So let's move this pencil. We are moving this pencil. So this is intersecting only one point. If we'll again move this pencil, it will intersect here, here, here. So every time it will intersect at one point. So this will represents a function. So this is a function. Next, take another example. This is representing a graph or any relation. Again, we need to check whether this is a function or not by pencil test. So let's take a pencil over left hand side, that is minus x. Now we will move this pencil from minus x to plus x, and we check whether it is intersecting at one point every time or more than one point at any time. So let's move this pencil. So we are moving this pencil. So starting with one point, and if we are moving further, so what is happening from this point onwards, it will intersect 2 points. So that means for elements of domain there are more than one element, that is image of 0 here in the graph is more than 1. So this will not represent a function because this is not satisfying the point of our definition of function, that it must be related with unique elements. So this is not a function. Now friends, let's check whether following function are discrete or continuous, and we have to find its domain and range. So here we have taken only discrete point, means you can observe here that on left hand side -1, -2, -3, -4, -5, -6, -7. So there is a point -7. For that we have an element. Then for 7 we have an image, then for 8, and then for 10. So we have not a continuous point, only few points. After this point, that is -7, we have directly at 1, and then at 5, then at 7, then at 8, then at 10. So this type of function is called discrete function. So what is the type? Discrete. What is the domain? So on x-axis, what are the points? -7, then 1, then 3, then 5, sorry, 7, then 8, and then 10. So this will become the domain. And then what is the range? Range will be is the image. So range is this point. Which is this point? So +1. Then this point. What is this point? It's 0. Then this point. What is this point? So this point is -7. Then what is this next point? It's 7. Sorry, for 7 it's 5. Then for 8 it is 2, and for 10 it is 8. So what are the elements in the range? That is 1, 0, -7, 5, 2, and 8. Let's take another function, discrete or continuous. What is the domain? What is the range? So first of all, what is the type? Here we have continuous point, not like the graph as before where only few points are there. So type of this function will be continuous. What will be the domain? So here our this graph on x-axis is starting from -8 and reaching towards +8. So domain will be a close interval from -8 to +8. What will be the range? So what is the range here? Below it is from -6 and above it is +6. So range will be -6 to +6. Next is the following function discrete or continuous? Domain, range. So clearly continuous. What will be the domain? Domain will be 0 to 45 because starting from 0 and 45. So domain is 0 to 45. What is in the range? The minimum point is 10 and maximum point is 70. So range is 10 to 70. Is the following function discrete or continuous? So here we are not having continuous point. So this is discrete. What will be domain? -7 to +7. And similarly range. What is the range? Range is, these are the points. So that is starting from 2. Minimum point is 2 and the maximum point is this point, that is 7. Okay. Now the set y where xy belongs to f is called the range. As we have seen what is in the range of the function, domain and range of function f from a to b are denoted by d of f. So this is the notation to represents domain of function f, and rf, that is range of function f. For simplicity, we refer to this set as domain and range of function f. Now, let's go a little bit faster to complete our topic. Some function and their graph. We are seeing the type of function. So, identity function. So, what is the identity function? So, in identity function, this domain and codomain both are same. It must be a non-empty set like we define in function. So, function from a to a defined by f of x is equal to x means image of every element will be itself. Suppose if I take element 2, so image of 2 will be 2, image of 3 will be 3. So such functions are called identity function. So if we plot a graph of this, suppose here in on the x-axis we are taking element of domain, and then we are plotting its images, that is range. So for 0 it's 0 as it is identity function, for 1 it is 1, for 2 it is 2, for 3 it is 3, for minus 1 it is minus 1, for minus 2 it is minus 2. So for this we get a graph like this, and this is nothing but a line y is equals to x. Now another function is a constant function. So constant function, if we find image of any element of the domain, we get a fixed element. Suppose here f of x is equal to c. So if you take any element from the domain x, its value of function or its image is only one element for all the element, which is c, then such functions are said to be constant function. For example, let's take function from 2 4 6 8. Means in domain there are only four elements, 2 4 6 8. 2 r means codomain is r, means all the real number. Now we are defining function like f of x is equal to 0. It's a fixed constant. Then what will be image of 2? So f of 2 is 0, f of 4 is 0, f of 6 is 0, f of 8 is 0. So for all the elements from the domain, image is a constant, which is 0. So such functions are said to be constant function. We can define in another way. Suppose f of x is equal to 10. So for all the elements, we are defining a relation or defining function like f of x is equal to 10. Then for all the elements of domain, what will be the answer? The answer will be 10. So again, a constant. So such functions are called constant. So how we'll draw the graph of? So for all the possible element on the x-axis of the domain, its answer will be a fixed constant. For example, c, and this is a c point. So for all the points of x, this will be the image. So we get a line y is equal to c, which is parallel to x, because for all the elements of x, we are getting a fixed answer. So such functions are called constant function. Next is modulus function. We are using modulus for modulus of minus 3 is 3, modulus of minus 4 is 4, modulus of 4 is 4, modulus of 5 is 5. But how it is defined? So it is defined like this: modulus of x is equal to, now there are two possibilities, whether that element, that number is 0 or more than 0, that is positive number, then its answer is the same element x. And if it is less than 0, that is element is negative, then what is the value of function? Minus times x. So in this case, x is positive, so answer is positive. In this case, x is negative and we are multiplying this negative element by minus. So again answer will be positive. So this function is called modulus function. So f of x is equal to modulus of x. Now if we plot the graph of this, so for 0, what is the value of modulus 0? That is 0. For 1, value of modulus of 1, it's 1. For 2, 2. For 3, 3. On left hand side, for minus 1, it is it is plus 1, because modulus of minus 1 is 1. Modulus of minus 2 is 2. So we will get a graph like this for modulus function. So if we take domain only of this left hand side portion, if we take domain only of this left hand side portion, not taking this, sorry, only of right hand side, then this function will become identity function, because image of 0 is 0, image of 1 is 1, image of 2 is 2. So if we restrict our domain towards for a positive side, then this function will become identity function. In identity function, we have seen that image of that element will be that element itself. Next function, signum function. So what is a signum function? So of a real line x, we do three parts of this. One part when x is positive, second when x is equal to 0, and third when x is negative, that is on left hand side. So on right hand side x is positive, at this x equal to 0, on left hand side it is negative. Now function is defined in this manner. F of x is equal to 1. It is 1 for all the positive value of x. That here we are getting value of all the values as 1. And at 0, it is 0. And on negative side, the value is minus 1. So from 0 to right hand side, function is 1. At 0, function is 0. And on left hand side, when x is negative, answer is minus 1. So this function is called signum function. This function has value from 1 or minus 1 according as number x is positive or negative. Next, polynomial function. Let a function g be defined as g from R to R. R is set of real numbers to set of real numbers. We can denote function by f, g, h, whatever you like. So here we have taken g. So function g from R to R, we are defining g of x is equal to an x raised to n plus an minus 1 x raised to n minus 1 plus dash dash dash. The power of x will be decreasing towards x raised to 0, and the coefficient is a0, a1, an minus 1 up to an. Then this g is called polynomial function of degree n, where n is non-negative integer, and this a0, a1, a2, an are constant real number. Here we call this polynomial of degree n. But for to be a polynomial of degree n, this x raised to n term must be present. And when this term will be present in the polynomial, so for this an should not equal to 0. So if an is not equal to 0, then this polynomial is called polynomial of degree n. This could be 0, no problem, because the degree of polynomial will be the highest degree of x, means highest power of x. So if it is polynomial of degree n, then this term must present. And when this term will present, when an is not equal to 0. Next, rational function. So rational function, I have taken two polynomial fx and gx, then hx is equal to fx upon gx is called a rational function, provided this denominator g of x should not be equal to 0 for any value of x. Then and only then this hx is equal to f of x upon g of x will represent or called rational function. So we define like this: h from r minus the value of x where gx become 0. We are excluding those points where gx is 0, and that is our domain to r. Then this hx is equal to f of x upon g of x is called a rational function. Next is greatest integer function. So what happens in greatest integer function? So we will see with the help of graph. This is also known as box function. See here 0 to 1. The value of x is 0 to 1. Then what is the image of that is 0. So from 0 to 1, what is the maximum possible number? Exclude 1. So that is 0. And that number must be integer. So from 0 to 1, image will be 1. From 1 to 2, what is the maximum integer? Then don't include 2. So from 1 to 1.9999, which integer is the highest? So that is 1. So from elements 1 to 2, its image is 1. Similarly, from 2 to 2.9999, what is the greatest integer? So that is 2. So its image is 2, and so on. So this function is also known as floor function. In Excel, we are using floor command. So when we take floor command, and if we are writing 1.5, then it will give you answer as 1. If you will use floor function 2.6, then it will give you 2. So such functions are said to be greatest integer function. Next is ceiling function. This is also same like that, but instead of taking greatest, we are taking least here. So from 0 to 1, now here exclude that. So this is called the ceiling function. So when we take ceiling function 0 to 1, it will take the higher values, the least integer not less than x. So 0 to 1, which is the least integer not less than this number. So for 0 to 1, it is 1. For 1 to 2, it is 2. So again, like floor, we are using ceiling function in Excel. So if I am using ceiling and if I am taking number 1.5, it will give me 2. If I am using ceiling and if I am writing 2.6, it will give me 3. So this is ceiling functions. Should I continue or stop over here? Can anyone reply from KS management? Should I continue or stop in few minutes? કેટલો ટાઈમ પોસિબલ છે તો હું એટલામાં ફિનિશ કરવાનું ટ્રાય કરું. 5-10 મિનિટ્સ, 5-10 મિનિટ્સમાં. Okay, thank you. Okay, thank you. Okay, so when algebra of real function. Now here we are taking function, two different function, and how to add those functions, subtract, multiplication. So we will take very fast so that I could finish whatever I have chosen to finish. So function f from a to r, g from b to r are two functions, and here a intersection b means domain of f is a, domain of g is b, and intersection of these two functions should not be equal to phi, means there must be some element in the intersection of a and b. So then in that case, how to define addition? Then function will be f plus g, and it is from a intersection b to r. So how addition function will construct? So domain of f plus g is intersection of a and b to r, and it will be defined as f plus g of x is equal to f of x plus g of x for all x belongs to domain that is a intersection b. Similarly, subtraction, it will be f minus g from a intersection b to r, and this will be defined as f minus g to x is equal to f of x minus g of x for all x belongs to a intersection b, that is domain. Next, multiplication by a real number. So real number, if I am taking alpha belongs to R, then alpha f from x to R will be defined as alpha f of x is equal to alpha times f of x. Similarly, multiplication. So fg from A intersection B to R is defined as fg of x is equal to f of x into g of x, and quotient f upon g from a intersection b. But here the condition in domain, like we have seen in rational function, from domain we will exclude the element where denominator, that is gx, become 0. So f upon g from a intersection b minus the points where denominator becomes 0 to r is defined as f upon gx is equal to f of x upon g of x. Let's take a very simple example. F from r to r and g from r to r. We have taken two function. F of x is defined as x square. G of x is defined as 4x minus 1. We have to find f plus g, f minus g, fg, and f upon g. So what will be here? You can see domain of f is r, domain of g is r. So intersection of r and r is nothing but r. So the first f plus g is from intersection of r and r, that is r to r, and f plus g of x is equal to what? F of x plus g of x. So what is f of x? Is x square. G of x is 4x minus 1. So f plus g of x is equal to x square plus 4x minus 1. F minus g from R to R. F minus g of x is equal to what? F of x minus g of x. So x square minus bracket 4x minus 1 bracket over. So if we open the bracket, this will become minus 4x plus 1. So x square minus 4x plus 1. And multiplication, fg from again r to r, fg of x is equal to f of x into g of x. So f of x is x square, g of x is 4x minus 1. So this will be x square into 4x, that is 4x cube minus x square. Then the last, f upon g. So we have seen for f upon g, we will exclude the element where denominator becomes 0. Here denominator is g of x. So we have to find the element where this element becomes 0. So where 4x minus 1 will become 0? So let's take 4x minus 1 is equal to 0. So 4x is equal to 1 and x is equal to 1 by 4. So at x equal to 1 by 4, answer of this is 0. So we will exclude that point 1 by 4. So r minus 1 by 4. So here what is the domain? not r. We are excluding the point where this denominator becomes 0. So our domain is r minus this element 1 by 4 to r. And how this will define? F upon g of x is equal to f of x upon g of x. So that is x square upon 4x minus 1. Now composition of two function. So how to compose it two function? So suppose if I have two function f from a to b, g from b to c. So if I am composing this two function f and g, so I can compose in two way, f o g or g o f. So suppose I am first defining g o f. So when we take g o f, then on x first f will be operated. Whatever the answer of that, on that g will be operated. So let's check the definition. Let f from a to b, g from c to d be two functions. Then h of x, this is the function, composite function for this GOF. And how h of x will be defined? So on this x, what will happen? F will be operated, and on the answer of f, g will be operated. So h of x is equal to g of f of x for all x belongs to a. So what f will do? F will send elements of A to B. What G will do? G will send element of C to D. So here A, C and D. These are the three sets they have taken. If I take element from A, it will send to C. Then on C, G will be operated. So that will send that element to D. Let's take an example. Let's A is equal to 1, 2, 3, 4, 5, B is equal to 1, 3, 5, 7, 9, C is equal to 3, 7, 11, 15, 19 and 23. Function F is from A to B, G is from B to C. By f of x is equal to 2x minus 1 means how f is operated on x. So for x, what we will do? We will multiply x by 2 and then subtract 1. How g is operated on any element x? We multiply x by 2 and then we add 1. Now we have to find FOG or GOF, whichever is possible. So here we can see the range of function is subset of B. Means if we will find image of this element, that is what is the image of 1 under f. So 2 into 1, that is 2 minus 1, that is 1. So answer of 1 is 1. What is the answer of 2 under f? So 2 into 2, 4 minus 1, that is 3. Similarly, what is the answer of 5 under f? 5 into 2, 10 minus 1, that is 9. So range of function is subset of B clearly is equal to domain of G, because domain of G is P and range of function is subset of P. So range of F and domain of G must be same. So hence GOF is possible. Now how we will find GOF? So GOF of X is equal to what we operate first? We operate F. Then we take g outside, we will operate f on x. So this is g of in bracket f of x. So this is equal to g of, what is f of x defined? 2x minus 1. So g of 2x minus 1. Now in this element 2x minus 1, g will be operated. Now how g is operated? What g is doing of x? So we will multiply x by 2 and then we add 1. So here instead of x, what we have? 2x minus 1. So we will multiply 2x minus 1 by 2 and we add 1. So what will be this? 2 into 2x, that is 4x. 2 into minus 1, that is minus 2 plus 1. So 4x minus 2 plus 1, that is 4x minus 1. So this is our composite function. So and how this will go? So GOF of from A to C, because what F will do? F will send element of A to B. What G will do? G will send element of B to C. So now GOF will be from A to C. So GOF 1. What will be that? Now we don't use F and then G, because now we have directly the answer of GOF, which is what? 4x minus 1, which we get after operating both of them. So what is GOF of 1? So 4 into 1 minus 1, that is 3. GOF of 2. What will that? 4 into 2, that is 8 minus 1, that is 7. Similarly for 3, 4 and 5. So GOF is from A to C, and these are the possible ordered pairs. So friends, the material I have taken here, the references for that is 11th standard textbook, and I have used internet also, because some of the presentation visualization what you have seen, that I have prepared with the help of internet. So if you want to study further, you can see this book of 11th standard, which is easily available on the website of GSEB. So I have tried to complete the topic relations and function, which is the foundation for calculus. So I hope it is clear. If you have any doubts, then you can mail me. My mail ID is Dushyant Patel underscore 1981 at the rate yahoo.co.in. So thank you very much, everyone, KS Management, Neeta Madam, and all the dear participants.
Thank you, sir, for such a knowledge sharing lecture. Now we are going to start a question answer session. If any participants have any question, they can type in a chat box.
So I will be glad to answer if there are any queries.
There is a no question, sir. On
Okay.
behalf of KA School of Business Management, I, Muskan Kalwani, thank you for delivering such an information talk. Thank you, sir.
Thank you, everyone. Should I end this call now? Okay, thank
Yeah, sir,
you.
you can add. Dushan bhai, you can add.
Oh, okay, okay,
You can end the call. Huh?
okay. Thank you, Jigar.
Thank you very much, sir, for your talk.